g at x. Okay, g at x. G at x is equal to x sine x squared. Okay, and then we're asked to find the integral of g at x dx. Now what do we do for this scenario? Well, same thing again. What we're going to do is we're just going to define our placeholders. So in this case, our box is going to be whatever's inside that sine argument here. Okay, so it's going to be x squared. Okay, I'm going to scroll up just a tad bit so you can see. Okay, so x squared. And then our derivative with respect to x of that placeholder is going to be 2x, like so. So now what we can do is we can move on to our next step. So we'll come on over here and write. We can substitute those placeholders in. So what we get is the integral of x times sine box dx. Okay, but as you can see, this is a dx and we want it to be in this form here. So what we can do is we can simply multiply this by the d box by dx here. Okay, so we get x sine box d box by dx times dx. And what you can imagine is these x's canceling out here. Okay, so when we substitute our numbers back in, we get this. We get x times sine of x squared times d box by dx, which is in this case 2x. Okay, now one thing we want to note here is that since we already have an x here, what do we have to do to make this 2x? Well, the answer is we just multiply by an extra 2. Okay, dx. So now these put together would be 2x, and as you can see, it is now in this form here. Okay, which is what we want. There's only one slight problem though. Is since we've added a 2, okay, we've added a 2, it has changed the expression. All right. So what we want to do, because now this right here does not equal our original expression, which is basically this. Okay. So what we want to do is we want to modify it a little bit so that the 2 basically cancels out. And the way we do that is we'll just put a 1 over 2 outside the integrand here. So we get x sine x squared times 2 dx. Okay, so now we are ready to integrate this. Okay, it's now in the proper form to integrate right here, because this expression still equals this expression right here. Okay, which we can write this as the integral of x sine x squared dx. Okay, it's the same thing. These two equal each other, and on top of that, okay, the integrand is in the proper form. So what we can do now is we can just convert. What this allows us to do is we can convert from this to this right here. Okay, so we can now put it in terms of cos whatever our placeholder is plus c. So we'll go ahead and do that. going to scroll down a little bit here. Okay. All right, so we'll get as our answer 1 over 2 times negative cos x squared plus c. Okay, and to simplify that, we can write it this way: negative 1 over 2 cos x squared plus c. And there would be our answer. So that's how you calculate the integral of a sine function.